A very good afternoon to all of you. This is the topic about the introduction to signals. So, already we have seen different types of signals, we have different shapes of signals, we have all around. So, let's start with the signal definition with the real world examples. So, very first, we will see the signals in general. So, a signal is a way of conveying information. That is a basic definition in general that we say a signal is a way of conveying information. It may have any shape in which form we are transforming the signals. It may be gestures, it may be semaphores, it may be images, it may be in the form of sound or speech signal. So in general, whatever information that we convey through any mode is a signal. But technically, signals are more than that, which technically it is defined as the signals are variables that carry information. Basically, it's a physical quantity or a phenomenon which is varying with some independent or dependent variables. Usually, we will take the time factor as our independent variable for observing any physical phenomenon around us. So, time is the basic parameter that is taken as a reference for any signal property. This is called as the temporal signal, the signal which is varying with time, that defines the relationship between its amplitude, that is a dependent variable, and the time, which is an independent variable. So that is basically a signal. Let us see what are different types of signals that we observe all around. The very first thing, biomedical signals. The signals that we observe normally in MRIs. So they are basically the physics around across this process is that signals are transferred in the form of magnetic energy, and we try to scan the body effects. Another type is that we found in communication systems, where the whole cellular mobile communications are communicating with end terminal devices through signals. And the most important part here is the satellite communication. So in satellite communication, all the satellites are communicating with the earth station on the earth. They are all in the form of signals. So we are having signals all around. And more than this, currently we are having a lot of signals when we are moving towards the 5G technology. So industrial signals. So all around the globe we are having numerous types of devices, and they are communicating in the form of signals. Like we have a base station in mobile communication, and a lot of mobile devices and different devices are communicating through the antenna. So that is the major that part requires the signal processing. So we have different signal processing methods, like we require modulation, enhancement in frequency of the signal. We have to deal with the frequency of the signal, different frequencies of the signal, signals associated with broadcasting and telecasting. So these are the basic examples that we see all around, and all are related to the signal processing. So broadly we can say that signal processing has a lot of applications, like it is used in audio signal processing, image processing, video processing, wireless communication systems, seismology, speech recognition, genomic signal, and many more. So the important thing here is that what are different attributes or parameters of signal to define it. We are having here the first attribute, that is amplitude. The amplitude defines as the variation of the signal or the fluctuation of the signal around its mean or average value. That is termed as amplitude. The second is the frequency. That is related to time factor, the time variation of the signal, how frequently the signal is changing. So that is called as frequency. Third is time period. So the time requires for completing one oscillation of the signal is termed as time period. And fourth factor is phase. That is basically the relationship between the two similar signals having same amplitude and same frequency, but they are lagging or leading according to their phase. So that is the phase of the signal. So these are the basic attributes of the signal that is used to define the signal completely. Remember, one important point over here is that any change in frequency does never change the amplitude of the signal, and any change in amplitude does not reflect any effect on the frequency. So they are completely independent with each other. So this is the waveform that we are observing here on the screen, that is representing all the basic attributes of a signal: amplitude, period, time period, frequency, and the wavelength, along with the phase between the two signals. So broadly, when we talk about the classification of signals, so they are defined on the basis of as a function of time, that means according to this independent variable, and second is category as according to its instantaneous value, that is dependent variable. So when we observe the independent variable time, we have continuous time signal and discrete time signal. And when we talk about instantaneous value, we have analog signal and digital signal. So function of time, we have continuous time and discrete time. That depends upon how the time is varying. And instantaneous value, we have analog and digital, how the values are changing. Next is about on the category of this continuous and discrete. We have four combinations for amplitude and for time variation. So first combination is continuous time and continuous amplitude. If we are having any signal which is continuous in time domain and continuous in amplitude domain, continuous means we are having infinite number of samples of a signal. That is called as continuous. So when we have both the parameters continuous, that is termed as analog signal. Second possibility is that the time is continuous but the amplitude is discrete. So it is defined as CTDA signal, continuous time, discrete amplitude. Third category is discrete time, continuous amplitude. We have discretized the time axis. That means we are having integer number of factors on the time axis and we have infinite number of samples in amplitude axis. So that is called as DTCA signal. And the last is when both the sections are discretized, that is discrete time and discrete amplitude. So that is termed as digital signal. So these are the broad categories or combinations, that possible combinations according to the continuous time domain and discrete time domain: CTDA, DTCA, and digital signal. So from this video we have concluded that signal processing is the forms the crux of all the new age buzzwords. Basically, signal processing is having the cross domain functionality with various sections like image processing, speech processing, pattern recognition. It is related to mobile communication, telecommunication, military applications, and a lot more. So this is the basic need that we have to learn about the basics of signal processing. Although this branch is very complex, but the interesting thing is that we are going to present all this complexity in the simpler way. Thank you.